in a laboratory, if you take cartilage cells, you know, this cartilage between your bones, your joints, you take these cartilage cells, you give them strontium, and they start producing glucosamine chondroitin. Glucosamine chondroitin, a lot of people are taking because they have sore joints. Well, if you're taking strontium, you get the body to produce this glucosamine chondroitin, and that's a lubricant between your bones. Now, if you're looking at strontium, may inhibit these osteoclast cells that stop or reduce your bone density. And studies, as I mentioned, will produce on these cartilage cells glucosamine chondroitin and hyaluronic acid, which is something they inject in the joints of athletes that really have worn out their joints, their runners and so forth. So there's a lot of speculation out there that these strontium will help, you know, arthritis. People who've got serious arthritis, this is something to look at. When we see high strontium in the hair, it means it's coming under your bones, it's leaving your body. So this is something we always look at with respect to bone formation or bone loss. So high strontium in the hair is an indication of osteoporosis, or basically it could be your body's become acidic. On healthy individuals, we see about 3 parts per million. On women with osteoporosis or men, it goes from 3 to 20, 40, 60. I've seen 120. So it's, you know, it depends how quickly your bones are shrinking, but we see this probably 10 years before the bone density test will ever see it. Bone density, you've lost 25% of your bones by the time they say, oh, you're losing bone density. So this is something to look at. The other thing is we seem to see a genetic link. Children of individuals that have got high strontium, which means they're losing bone density. We've done a grandmother that was in her 70s, and she had very high strontium in her hair, and she was diagnosed with osteoporosis. We've got her daughter, which was 40, not diagnosed with anything, but she had the very same profile. And we did an 18-year-old granddaughter, same profile. So there seems to be a bit of a genetic link there. And I think if your parents have had bone problems, there's a good chance you will too. This is a hair analysis report, and it's those red lines you see at the top. The first red line you see, that's lead. So this individual, this by the way, is a 10-year-old girl. A 10-year-old girl, and she's having epileptic fits. So she's seriously ill. They went to the doctor, they gave her anti-epileptic medication. It didn't work. She's still having fits. So the girl's mother took her to a naturopath. Naturopath sent us a hair sample. And the second red line you see up there, it's quite high, that's cadmium. Very, very toxic. Now, how does a 10-year-old girl load up on cadmium? You know, that's something industrial worker might have if they work with the materials, but how does a 10-year-old girl end up with cadmium? Well, in all likelihood, that came from costume jewelry. Health Canada has a notice out there right now to be aware of costume jewelry coming from China contains cadmium. And Health Canada notice talks about children may put this costume jewelry in their mouth. And that's one way of getting it, but just wearing it, it goes through your skin. Now this girl is 10 years old. It'll probably take 30 years for that cadmium to come out of her system unless they do chelation therapy or something else to displace it. But it's a serious problem. And this girl also has, if you go down the next two big red lines, calcium, magnesium. The next one after that is strontium. She's got, her system is probably acidic. And when you're acidic, your body protects itself. It wants to neutralize this acid, and it dissolves bone. The alkali metals in bone, the calcium, magnesium, strontium, to neutralize the acidity in your body. So she's losing bone density at 10. So this is not a healthy situation at all. The other red lines, if you go down the second from the bottom, the big red line, or the very one at the bottom, that's nickel. And where would you get nickel? Costume jewelry again. So she, it's a good indication that's where she's getting the nickel from, is the costume jewelry. The line above that is manganese, that's off the scale, which would indicate, based on what we've looked at, she's got sugar issues. So she's epileptic, she's got bone issues, she's got sugar issues, she's got these toxic metals in her body. This is a 10-year-old. So it's amazing what you see in this. Not a very nice picture, but hopefully somebody will be able to resolve her issues. Now back to the bones, there was a Harvard University study, 36,000 women, and were given 1,000 milligrams a day of calcium, and another group was given a placebo. And this is for bone formation. We all hear you need to take calcium. There's calcium caltrate, and there's all kinds of prescription calcium products out there today. The results were the same for each group. They all took vitamin D, by the way, because there's a theory out there that calcium is not absorbed unless you've got vitamin D. Well, they both took vitamin D. No change with the calcium supplement. So calcium did not make a difference in this study. The Mayo Clinic, you may have heard of the Mayo Clinic. They looked at women 80 years old. Adding strontium decreased the risk of bone fracture by 59%. There's a study in the New England Journal of Medicine, basically showed that the risk of fracture reduced by 49% in that study. A control group in the studies, they both consumed calcium and vitamin D and did not show any reduction. If you had calcium and vitamin D, if you're 80 years old, your bones are still fragile. If you take strontium, it seems to make your bones more flexible, stronger. I gave this presentation at Dalhousie University, and there was a theoretical chemist that was showing me around the university. I mentioned this to him. He says, it makes absolute sense. He says, and I don't understand this part of chemistry, but he says, the bond with strontium is a lot more flexible than calcium or magnesium, and it makes absolute sense that the bones you're forming with strontium are a lot more flexible. I have an aunt in Florida who has osteoporosis, and she's got it pretty badly. She's broken every bone in her body. She'd hit the table like this, she'd break a finger bone. She's in bad shape. Anyways, I told her you should start taking strontium. So I gave her some strontium, and she was taking it for 4 or 5 months. And I was in Florida in February, and she was standing next to me, and she tripped on the carpet. And she fell flat in her face on the concrete. Now, I said, this is it. She's broken a hip. I cleaned her up, there was a lot of blood, but she didn't break anything. This, unheard of. It's never happened before. Every time she falls, she breaks something. So, I'm a strong believer in it. Another story I can tell you is my mother-in-law, who had osteoarthritis in her spine. So she'd be bent over, a lot of pain. The last 5 years of her life, a lot of pain. I'd see her, crying on the kitchen counter, bent over, just in terrible pain. So my wife was diagnosed with the same thing. They did an MRI in her spine, says, you've got advanced, and she was having back problems. And so she was really, really depressed. She was crying, I'm going to end up just like my mother. Anyways, I put her on strontium. And now she's dancing. She doesn't feel her back anymore. So I'm a strong believer in it. Bit down? Closer? Lower? Okay. McGill University did a study, and basically supplementing your diet with strontium showed that just 6 months, participants increased bone formation by 172%. Now I should say all of these 3 studies have been put down by the pharmaceutical industry saying they weren't properly regulated and so forth, and they stand to lose billions of dollars if we stop taking their calcium products. But anyways, in Europe, you can get a prescription strontium medication, and it has a great cure rate for osteoarthritis in the back. So this is what they prescribe. It is not available here in North America. So I don't know if it's the pharmaceutical industry that's stopping it.
Which one do you like to use here in Canada?
We just buy it at the store, strontium citrate. It's strontium rainate they use in Europe. And maybe it's better absorbed, quite possibly. But it's a matter of getting strontium into your body. But you don't take it if you're taking calcium at the same time. One will stop the other from being absorbed.
Because I've seen somewhere they sell strontium with calcium. So we have to watch that.
Yeah, there's a lot of, like I said, that diagram I showed you, there's some things you shouldn't be taking with others. We should have a vitamin pill for the morning and a vitamin pill for night, where you try to separate some of these things so you get better absorption.
How many milligrams of strontium in the study? How many milligrams of strontium in the study?
Good question. 500 milligrams or something like that. 400, 500. I think so. I'd have to check. I don't have it off the top of my head.
Maybe micrograms.
No, it would be micrograms. It'd be milligrams, yeah. When I looked at my wife's hair, she was very high in strontium, so it's leaching out of her bones. It's leaching out of her cartilage. And after she was on strontium for almost 2 years, I checked her hair again, and I said, oh, it's going to be very, very high. It went from 60 down to 15. So your body used what it needed and got rid of, there was no accumulation built up in the hair, which is good news. I'm going to move on to another thing that we're all interested in, is carbohydrate metabolism, diabetes. And as I mentioned earlier, there's several elements that are involved: chromium, vanadium, zinc, magnesium, but I'm going to talk about manganese. I'll just talk about one of these. And manganese has a major role. Animal studies, if you look at manganese deficient diets, they have a typical diabetic glucose tolerance curve. So manganese is necessary for the metabolism of sugars. If you're deficient in manganese, you're going to have dizziness, ear noises, your impaired glucose tolerance, and increase in fat deposition. Now, here's a co-researcher of ours. If you look at the left-hand side, those are spikes in manganese. This is manganese in the hair. And those spikes, that little hump you see on the left-hand side, this individual, who was a good colleague of mine, friend of mine, was diagnosed with type 2 diabetes. At that point, he's got type 2 diabetes. And the second red arrow is he's been giving metformin. It's the first thing you get when you're type 2 diabetes. So he's been given metformin, and the manganese drops down to normal levels. So you go along for 4 or 5 months at normal levels, and all of a sudden, my friend is Egyptian, and he's stubborn. He says, I'm cured. I don't have a problem, I'm cured. So he stops taking his medication. All of a sudden, the manganese pops up again in the hair. The symptoms of diabetes are showing up again. So he's got a problem again. So the next arrow, he starts taking his medication, and the manganese drops. And it keeps dropping. And 3/4 of the way over here, he stops taking his medication, but he's lost 50 pounds of weight. He lost 50 pounds of weight, and type 2 diabetes is gone. So type 2 diabetes is related, in a lot of cases, to weight issues. I'm also going to talk about, after this, oxidative stress, and it causes diabetes also. But in this case, the weight seemed to resolve the issue. Oxidative stress. Now, what is oxidative stress? Basically, it's an imbalance between the production of reactive oxygen species. what we call free radicals. For those of you not chemists here, free radicals are really reactive species, and they can cause a lot of problems in our bodies. This is why we take antioxidants, vitamin C. But when you're generating more of these free radicals than your body can handle, that's oxidative stress. Every one of us right now is generating free radicals, and every one of us, our body is handling it. Free radicals will destroy some proteins, will attack DNA, will do all kinds of nasty things in our body, but the body can handle it. If you're healthy, your body can handle it. But you get to a certain point where the body is generating so many of these free radicals, your body can't handle it, and that's where you start some pretty nasty diseases. Things like cancers can start. So you do not want to get into an oxidative stress situation. Now, what can cause some of this oxidative stress? Well, we believe there's a lot of it is copper and iron interaction. Now, we think oxidative stress, a lot of it is caused by too much iron in our system. And the iron we have in our system basically is absorbed as ferrous. This is ferrous. Iron is what we absorb in our stomach. If you eat red meat, that's ferrous iron. That's the red meat, the blood, that's ferrous iron. You're absorbing iron. If you're eating lots of vegetables, it's the ferric that you're absorbing, but ferric is not absorbed well in the stomach. So what you need at that point is you need something like vitamin C to reduce it to ferrous, then it's absorbed well. So iron is usually oxidized, I should say, ferrous is what you absorb in your stomach. What's used in your cells is ferric. You need the ferric to be used in your cells. So converting ferrous to ferric is usually done by a copper-containing enzyme, peroxidase, and it accounts for about 70 to 90% of the copper in your serum, in your blood. So if you don't have enough copper in your system, you're not generating enough of this ferric that your cells need, and you're accumulating a lot of this ferrous, which is surplus. And ferrous is what will react with oxygen species to generate free radicals. And that is not a good situation. An ideal ratio in the hair of copper to iron is 1:1. If I look at the hair of people that have reached 100 years old, and we have, they have a perfect ratio of 1:1, copper to iron. It's beautiful. We don't always have that when we're younger, when you've got this oxidative stress. I don't know if you can see this, it's a little dark, but basically DMT is divalent metal transport enzyme, which transports the ferrous into the cell. And if you don't have enough DMT, accumulation of divalent metals, especially iron and manganese, are frequently discussed factors in a variety of diseases like Alzheimer's, Parkinson's. Remember we all talked years ago about Alzheimer's being aluminum? Remember aluminum was the big thing we worried about? It's not aluminum anymore, it's iron. We're worried about too much iron, too much of this ferrous adding up in your body. And this enzyme that transports the ferrous into the cell where it can be used up as it needs to be. As we get older, there's less of it in our body. So there's more chance of accumulating this ferrous in your body, which will generate those free radicals we don't want. So if I look at high iron in the hair, my healthy individuals have about 13 parts per million or less. The sick individuals, the people with the cancers and so forth, 10 times more, 123 as an average, and those that were deceased had about 70. Again, an elevated level. But the sick individuals had elevated iron, basically showing oxidative stress in their body, generating all kinds of nasty diseases. So high iron in the hair is not something you want to have. This is that reaction. The Fe is iron with two little plus signs. That's your ferrous. Reacting with peroxide, reactive oxygen species, giving you ferric and a free radical. That OH dot is a free radical. That free radical, as I said, will attack anything. Very, very reactive. If you're diabetic, the oxidative stress damage in diabetes, type 2 diabetes, guanine is that molecule you see on the left. That is one of the 4 building blocks of your DNA. There's 4 base pairs that are used in DNA. All of our DNA. And guanine is one of them. And with that free radical OH dot, you see you can measure this 8-hydroxy guanine in the blood of diabetics. So there's oxidative stress happening in diabetics, type 2 diabetics. So you're causing damage, you're showing it, you can measure it in the blood. There's an issue. Imagine if that's happening to guanine, it's happening to DNA. And we know a lot of the cancers are caused by viruses and so forth, but a lot of cancers, it's a mathematical thing. We damage our DNA, our body fixes it, tries to fix it, but if you keep damaging it all the time with these free radicals, then the cancer is going to get out of control. What causes iron overload? Well, tobacco smoking, external red meat, lots of red meat, alcohol, bacteria, UV exposure, genetics. There are some genetic diseases that will have high iron in your system. Environmental pollution, different foods we eat, and something which you probably don't think of, stress. Stress is a killer, and I'm going to show you some case studies on stress. Anyways, to be healthy, I've been talking about different metals. I've been talking about the calcium, zinc, selenium, magnesium on the left. But there's also, you need some high quality food in your diets. And I'm going to talk about different berries, things like garlic and nuts and vegetables, that a lot of them have been shown to fight different types of cancer. So I'm going to cover some of those in my presentation. We talk about oxidative stress. Well, what kind of antioxidants can we take? Well, in the fruit and berries, the best antioxidant you can take is blueberries. And if you take watermelon, you're getting 216. This is a measure against vitamin E. Watermelon's 216 better antioxidant. But look at blueberries, 13,000. Cranberries, 9,000. Raspberries, and so forth. And you go down. So if you had high iron in your body,